Welcome to All This Math. This is Professor Parker, and today we're going to talk about word problems. Now, I know for a lot of us, word problems are the bane of your existence, but word problems are the actual application of the math that we need to be doing. All right? So we need to develop certain skills to be able to approach and solve word problems, right? And one thing that would help us is if we just thought about mathematics as a language in and of itself. When you think of mathematics as a language in and of itself, then you start to think about how to translate information from, as an example, in this word problem, from the English language into what we consider a mathematical language or a mathematical way of expression. In math equations, we have a whole bunch of expressions that are set equal to each other. Sometimes they're greater than each other. Sometimes they're less than each other. And if we just understand that as a concept, then word problems wouldn't be that intimidating or daunting for us, right? Before I get started, I want to make sure that everybody who's watching this video is subscribed to the YouTube channel. I want you to also turn on the notifications so that way you'll get an alert when I put out new content. And also, you know, if you find value in this video, go ahead and hit the like button. All right. So, as I said, we have a word problem up here. And first thing we need to do is read it. All right. Because I tell my students all the time, like a lot of, and let me back up a little bit. Let me address something that is a misconception. In mathematics, a lot of people feel that reading is irrelevant in a mathematics space or in a mathematics classroom or when you're trying to complete a math problem. That couldn't be further from the truth. Just like when a lot of people say, well, you know, I'm a reading person, I'm not really a math person. And then some people say stuff like, well, I'm a math person, I'm not really a reading person. You can't really separate mathematics from reading comprehension. They're both two types of literacy. One is numeracy and one is through words, you know, a verbal literacy, if you will, right? You can't really separate the two. For example, how can we do a word problem if we can't read? Even if we can solve equations, but we can't really read and interpret and fully understand the words, how can we solve a word problem? We can't. So before we even get into the actual math and the calculations, you got to be able to read for real. You got to be able to read, right? So let's read this. There are 10 less trumpet players than saxophone players. All right. First sentence, one sentence at a time, one word at a time. Make sure we process the information. All right. And also, here's another thing. Don't be intimidated by word problems. As long as somebody shows you how to do them, you'll be able to do them and you'll be fine. But a lot of times we get caught up in our fear and our intimidation of them, and we never are open to learning how to actually do them. Right. So don't be intimidated by them. All right. Just learn how to do them and then do a whole bunch of them until they become easy. Once they become easy, then it's nothing to it. All right. But you got to put in the work. You got to learn how to do them and then do a whole bunch of them. Those are the keys. Anyway, sentence number 2. The number of saxophone players is 3 times the number of trumpet players. All right. Next sentence. How many trumpet players are there? So that's our main objective, to figure out how many trumpet players there are. Now I'm reading this question and I'm thinking about saxophone players. I'm thinking about the late John Coltrane. Trumpet players, I'm thinking about Louis Armstrong, right? So here's like a hystematics connection, right? We can connect this word problem to larger conversations about John Coltrane and the musical community that he was a part of, Louis Armstrong and the musical community that he was part of, and also the larger, you know, political involvement that both of those brothers had, right? So that's another conversation we can have at another time. But at any rate, with this particular problem, the first thing you want to do is, after we understand what is our objective, to find out how many trumpet players there are. All right. We're going to translate this whole word problem, these 3 sentences, into one equation. One equation, right? We're going to condense it all into one equation. The first thing we want to do is like pull out important information, right? So we know that there are 10 less trumpet players than saxophone players. All right. So whenever you see a word problem and there's a comparison between 2 entities or 2 amounts or 2 things, here the number of trumpet players is being compared to the number of saxophone players. You will often see word problems like that. What I do, you don't have to do it this way, but one thing I suggest, and one method, is the second item that's described, we make that X. The second item that's described, we make that X. That's a pro tip right there. I just put you onto a pro tip. The second item that's described, just make that X. So in this sentence, the first thing that's described is the number of trumpet players. The second thing that's described is the number of saxophone players. So what I'm going to do is this. I'm going to do this. I'm going to say let X equal the number of saxophone players. All right, because we let the second thing that is described or that is mentioned, we let that be X. Now, so in relation to that, now we have to describe the trumpet players. Now it says that there are 10 less, right? 10 less trumpet players than 10 less than, right? So we got to know how to translate that. We got to know how to translate that. So basically what we're saying is however many saxophone players it is, the number of trumpet players is 10 less. Now, a lot of people will make the mistake. They'll say, oh, well, you know, that means the trumpet players is 10 minus X. Nah, it's not. We got to think critically about what that really means. 10 less than this. So that means whatever this is, which is X, 10 less means you're subtracting 10 from this. You're subtracting 10 from the number of saxophone players. So that means we're going to do this. We're going to say X minus 10 is equal to the number of trumpet players. X minus 10 is equal to the number of trumpet players. So again, a couple rules. When two different items in a word problem are being compared, the second item, we call that X, or whatever variable you want to use. You can use J, you can use R, you use the first letter of your name, it don't matter. But we just use the single variable to represent the second item that's included. All right. Then we compare the first item to it and we create an expression. All right. Now we go to the next sentence. Next sentence says the number of saxophone players is 3 times the number of trumpet players. So the number of saxophone players. Now this is when we get into setting up the equation. We take the information and we create an equation, right? It is 3 times the number of trumpet players. So again, this is a language. We're going from English language to math language. English language to math language. The word is represents an equal sign. And it says the number of saxophone players. Look at this right here. This is the number of saxophone players. X in this language, in the math language, we're using X to represent the number of saxophone players. Just like if we were dealing with Kiswahili, going from English to Kiswahili, and Kiswahili to English. If we were doing Arabic, going from English to Arabic, Arabic to English, it's the same thing, right? So here, the number of saxophone players is going to be X. So I write X. Is, the word is means equal sign. That's the equal sign in algebra, right? And then it says 3 times the number of trumpet players. 3 times, that means multiplication. You're multiplying the number of trumpet players, which is X minus 10, by 3. Now, this is something you got to be careful about. When an entity or object is an expression, meaning more than one term, right? Or, well, you can have an expression with one term, but when you have an expression that's got more than one term, you got to put that expression in parentheses. So I'm not just going to put 3 times X with the X next to it. You got to use parentheses. So you put the X minus 10 in parentheses. Now look what I did. All I did was translate this whole word problem, the first 2 sentences, into this equation. So we just condensed it. We took out the important information and we created an equation. And this is why reading is so important, because reading comprehension and understanding the language of mathematics is key for this. Because a lot of people could solve this equation. I've encountered a lot of students over my years of teaching that could easily solve this equation if you give it to them. But a lot of those same students, they would not be able to read this word problem and then pull out and create the expressions, do this, and then create the equation and then solve. And it's because they haven't been taught. So the purpose of this video is for me to teach you how to do this. So whenever you see a problem like this, you follow the same format and the same protocol to be able to create the expressions and then take the expressions and create the equation. So again, second sentence, the number of saxophone players, which is X, right, is, which means equal sign, 3 times the number of trumpet players. 3 times, that means multiplication, no symbol in between, the 3 in the parentheses, the number of trumpet players is x minus 10. And that's why it's important to like label your terms or label your items or label the different parts of the problem. Because a lot of people, they see a word problem, they jump right in and just go straight to the equation. You could do that when you get the hang of this, but I recommend still label everything. Let people know, like let it be known, okay, what is x equal? Then what is this other item inside the word problem equal? So now we're done with the word problem part. Now we're just doing the straight algebra. So we got x equals 3 times the quantity x minus 10. We don't say 3 parentheses x minus 10. We don't do that. This is a quantity. X minus 10 is a quantity. First thing we want to do, we want to get rid of the parentheses by doing distribution, distributive property. So we do 3 times x and we do 3 times negative 10. So over here we got 3x minus 30. Positive times a negative gives you a negative. All right. Positive times a negative gives you a negative. Don't forget that. Then you got x over here. X equals 3x minus 30. Now we got an issue. We got too many x's. We got an x on the left side. We got an x on the right side. So what I'm going to do is I'm going to transpose. Many textbooks will tell you to just subtract 3x on the right side and subtract 3x on the left side. That's cool. We could do that. Or we could just pick the 3x up, move it over here. That's called transposing. That's what that's called. It's called transposing. But when you move the 3x over, you have to change the sign of the 3x. Right now, it's a positive 3x. But now we're going to change it to a negative 3x. So we got x minus 3x is equal to negative 30. X minus 3x is equal to negative 30. Now, what was the point of me doing that? The point of me doing that is so that I can do what's called combine like terms. These are like terms because they both have x to the first power in them. X and x. You can put them together. All right. So I got 1x minus 3x. Leaves me with negative 2x. And that equals negative 30. So now I want to solve for x. So now I got to only get rid of this negative 2. So this negative 2 got to go. So how do I get rid of the negative 2? The way you get rid of the negative 2 is do the opposite operation from what negative 2 is involved in. Negative 2 is involved in multiplication with the x. The opposite of multiplying is division. So we divide by negative 2 on the left side. We divide by negative 2 on the right side. Boom, boom. Now let me slide up here. Finish the problem. X equals positive 15. When we divide a negative by a negative, we always get a positive quotient or a positive result. The same rule applies to multiplication. In mathematics, 2 wrongs do make a right. 2 negatives do make a positive with multiplication and division, though. So let's be careful. So we got x equals 15. Now let's go back here. X is the number of saxophone players. So therefore, 15 is the number of saxophone players. But the question is, how many trumpet players are there? So you got to be careful with this because you might see a question like this on a standardized test, and it might be multiple choice. And one of the answers inevitably will be 15. And you did all this work and did it correctly, right? But if you mark off 15, your answer will be wrong because keep in mind, again, reading is fundamental. Reading is fundamental. They ain't asked you how many saxophone players it was. That's not what they asked you. They asked you how many trumpet players they are. So the trumpet players is x minus 10. So if you know x is 15, replace the x with the 15, do 15 minus 10, which is 5. Right? And we can also check our work, right? So now we go back and we say, okay, well, if I think that it's 15 saxophone players and 5 trumpet players, does that gel with the information in the problem? The problem tells us that there are 10 less trumpet players than saxophone players. Is 10 less than 15? It is. So it checks out based on the first piece of information we were given. Then it goes to the second sentence and says the number of saxophone players is 3 times the number of trumpet players. So is 5 times 3 equal to 15? It is. So that's proof that our answer is right and that the number of trumpet players there are is 5. And that's the answer. And that's how we do word problems, right? So I gave you some tips on how to approach word problems. Remember, when two different items are being compared within a word problem, make the second item x. Just make that your x, and then you go back and create an expression to represent the other item that's being compared to it. So in this case, the saxophone players, the number of saxophone players was x because that's talked about second. The number of trumpet players is talked about first. That's the pro tip. When I learned that skill, when somebody taught me that, put me on to that, that just changed the game for me. Then it was like, oh, whenever I see a problem like this, I know what to do. I know how to start it. A lot of times we get caught up because we don't even know how to start these problems, right? But that's one definite way to start these problems. It's not the only way to do them, but it's one that's a surefire way it's going to work. All right. And then we figured out that, you know, there are 15 saxophone players. And then from there, we figured out that there must be 5 trumpet players. So we combined our reading comprehension and our ability to translate the English language into math language, and then use algebra to solve for our unknown value. All right. So again, please subscribe to the channel if you have not already. Please turn on the notifications. Please like the video. Hopefully you learned something new today. So go ahead, like the video, and share the video with some other people. Share it with somebody. Let some other people know about the content we have here on the All This Math YouTube channel. And as always, please do remember that there's all this math all around you. Peace.